Consider the region bounded by the curves f of x equals 3 root x and g of x equals 3x. See below to answer the following. So you can see they got this diagram here. The curved one must be the 3 root x. The straight line, y equals 3x, because, x and y are just the first power. No curvature, straight line. Okay, so you want me to find the volume of the solid obtained by revolving the region about the x-axis. So this is the x-axis right here, as you know quite well. And so we're going to revolve this whole thing. And it's going to basically, you know what it's going to do? It's going to, um, it's going to go down like that, isn't it? And there's going to be like a little that curves out like that, right? That's what's going to happen when we revolve it there about the x-axis. So we're going to get that kind of shape. Well, three-dimensionally, there's specifically what it looks like on the 3D calculator thing. So here's the flat. So I just put in 3 square root of x and 3x. And I went from a 0 to 1. And there's the flat. And then you rotate it. Here's 270 degrees, almost completed. It's a big frisbee thing with the hole in the middle, isn't it? Okay. So therefore, what are we gonna do about this thing? So we're going to find the volume. How do you find the volume? Well, the volume for each washer is pi outer radius squared minus pi inner radius squared times the thickness, right? Because think about a washer. You have the inner radius, the outer. The little r is the inner radius. The capital R is the outer radius. And so you can find the area of the whole circle, that's pi capital R squared, and then subtract, take away the circle in the middle, the hole in the middle, pi little r squared. That'll give you just the washer, the donut, just this shading part, right? The whole circle minus the inner side times the thickness. The thickness is going to be dx. You can see that right here, right? The thickness of each of these is dx on the x-axis. Even on the 3D, you can see it. This is the x-axis. This is the y. The thickness is going this way. We're stacking them up dx, okay? And then also there's dx here. So thickness is dx. Okay, so then we just need to figure out this stuff. So this is going to be pi capital. Now, what's capital R? What is capital? Let's go back. This diagram's a nice one. Capital R is going to be all the way from here up to there. That's capital R. Put that big. That's capital R. And then the little r, just right there, right? The outer radius, inner radius. You can see that over here too. See on the 3D version, see there's the line they put this line. So you can see this disc. This is to the outer edge. This is to the inner edge. Right. So the outer edge radius then is going to be the y value on this graph. What is that graph? That's y equals 3 square root of x. 3 square root of x. And the little radius is going to be the y value on the other one, which is just 3x. This one. So there we go. So then we just come back and go, oh, that's easy. So this is going to be 3 square root of x squared. It's going to be 3x squared. And the thickness is dx. And then we're going to integrate that thing from x equals to x equals, because we're going dx on the x-axis from 0 to 1. You can see, right? So we're stacking them even right here. From 0 to 1, we're stacking them up. Stacking the disks from 0 to 1. And there we go. And that's how they get their answer. From 0 to 1, they put the pi in the front. 3 squared x. That'll be 3 squared, and that'll get rid of the root. You can type it in this way. It'll take it just fine. This is 3 squared x squared. And there we go. That'll be the volume of that shape with washers.